Yeah. In last few classes, we completed recursion, recurrence relation solving. These are the basics which are required for a divide and conquer. I already mentioned to you that time also. Right? What are the basics required for divide and conquer? Recursion, recurrence relation solving. I hope you are comfortable with these three. If you are comfortable these three, now current chapter which is going to be happened is, right, divide and conquer. See, I written also divide and conquer. So if you are comfortable with those basics, right, this chapter becomes very simple. Suppose assume that you are not comfortable somewhere, right, please revise again. So nothing is there is in life there is nothing called impossible and all. Right, if you think that something is impossible, right, that may be really a nice topic, that may be really dangerous, that is the reason you are thinking impossible and all. Right, so if we keep on practice, right, suppose some topics immediately will come, some topics may take one day, some topics may be required 2 or 3 revisions. So what I want to say, everything is possible, some will take less time, some will take more time. Those things which are taking more time, right, it doesn't mean that not possible and all. It is possible, right, maybe they are really tough and all, that is the reason it is taking some more time. Please revise again. All the basics of divide and conquer, whatever I said, please revise again if you are not comfortable. And one more thing I want to say to you. Whenever divide and conquer chapter is going on, those basics you will see again and again. So please be comfortable at least now. Right, let's concentrate here. Topic name is divide and conquer. Right, please be careful. I am starting. Divide and conquer. Before going to the divide and conquer, right, let me give small introduction about the divide and conquer. Please see. So let me say one small story. Right, afterwards we will go to the divide and conquer. Let me say this. Listen everyone. Listen. I have a assume that I have a one problem. Assume that I have a one problem. I want to get solution to that problem. I have a one problem, I want to get solution, right, to that problem, which is nothing but I want to get algorithm to that problem. I have a problem, to that problem I want one algorithm, right? If you have a problem, you want one algorithm for that, right? One of the way to write that algorithm is going to be divide and conquer. Instead of writing blindly, don't write everything from scratch, right? Don't write everything blindly, right? What will you do is, there is a one algorithm called, right? There is a one algorithm is called divide and conquer. You have a problem, you want to write algorithm to that problem, right? One kind of algorithm you can write, that is called divide and conquer. What's the divide and conquer, right? I will explain now. I will explain. Let's see this one. Again I am repeating some other story, please listen. Please listen now. So divide and conquer is saying that don't write algorithm for any problem blindly, right? So I am already there. Please, you can use me. That's what the divide and conquer is saying. Divide and conquer is saying that I am one kind of algorithm to your problem, right? I may be the one of the solution. You can use me. That is the one thing what the divide and conquer is saying. And one more. Let me say this point also. Carefully listen. Let me say this point also. Assume that in your personal life, you got very complex problem, very difficult problem. In your personal life, you got one complicated problem, very difficult problem. You are thinking that it is a very complex problem, it is a very big problem. You cannot solve this problem at all. In your personal life, you got a very complicated problem, which you are thinking that it is very difficult and very big also, right? You cannot solve this problem at all. You are thinking like that. To that problem, you are thinking no solution at all because it is looking like very complex. Whatever it may be the problem, in your personal life, you have some problem, you are thinking that to this problem, no answer at all. Right, because it is a very big problem, no answer at all. You are thinking like that, right? Instead of saying this problem I cannot solve at all, instead of saying like that, right? What the divide and conquer strategy is saying is, if you cannot solve if you think that problem is a very big problem, instead of saying I cannot solve, best idea what you can do is divide that problem into some small problems. Instead of saying I cannot, this may be better idea. What is that? Divide the bigger problem into some small problem. So actually you have a one big problem, you are thinking it is not possible at all, then what will you do is divide that one problem into 4 small problems. P problem, which is the big problem, you divide it into, right, 4 sub problems, P1, P2, P3, P4 like that. Now what will you do is, instead of saying P I cannot solve, one better idea is going to be P1, P2, P3, P4, which are the subproblems of P, right? Please at least solve these subproblems. If you can get the subproblem solution, most probably, right, by combining somehow all those subproblems, you may get the final problem answer. That's what the divide and conquer is saying. Divide and conquer is saying that you have a very complex problem, very big problem. You are thinking that this problem you cannot solve at all. Instead of saying I cannot solve at all, best idea, divide at least that bigger problem into some small problem. Solve small problems individually. Afterwards combine them. You will get the final problem answer. That's what the divide and conquer strategy is saying. And one more, let me give one more real-time example also. See this one. India is a huge country. India is a very big country. In India, for every human being, right, providing the minimum facilities is very difficult because huge crowd, huge population. India is having huge crowd, huge population. Providing all basic facilities for all the human beings are very difficult. Providing food to everyone, providing shelter to everyone, providing water to everyone. So all the human beings providing basic facilities is very complex story. So instead of saying India is a big country, we cannot provide like that, instead of saying I cannot do, it is not possible at all, instead of saying that, what is the best idea? Divide the India, total India, which is a big country, into small parts, which are known as states. You divided the big country into small parts, which are nothing but states, right? Now what will you do is, right, in every state, whatever people are there, please try to provide basic facilities for every human being who is there in that state by Chief Minister. Total Prime Minister cannot do all. So he divided the total country into some small parts, which are known as states. So in every state, Chief Minister is covering all their people basic facilities. So if every state is doing like that, right, that indication that a complex problem of India is solved. Divide the bigger one into small one, individually small the things please try to complete, then automatically total country problem will solved. Some people are asking me, in the state also, for every person, how you are providing basic facilities, right? Then what is the answer? Again, state will be divided into small parts, right? Those are known as districts, right? Every district, whatever human beings are there, please try to provide basic facilities for them. Right? If you can do that, all the districts, right, this kind of thing is going on, then automatically that state will be in the good state. If all the states are in the good state, automatically country will be there in the good state. That's what divide and conquer, right? Total country ruling is very difficult, so divide it into states. Total state ruling is very difficult, divide into districts. Total district ruling is very difficult, divide it into some villages, something like that. That's what the divide and conquer is. Instead of, if any complex problem or big problem will come, instead of saying this problem I cannot solve because of it is a very large problem, divide and conquer saying that, right? If you cannot do total, at least to do small. At least to do small. If you can do small, bigger one also you can do. That's what the divide and conquer strategy is. I'm thinking that almost you got the clarity. Little bit doubt also there in the divide and conquer chapter. Anyhow, you will get to know all the details, right? Let's start the divide and conquer. See this one, divide and conquer first step. See the first step. Divide and conquer. See the first step. First step of the divide and conquer is going to be, see this one. This is the first step. Divide. See this one. Divide the big problem into. Divide the big problem into some smaller subproblem. Into some subproblem. Divide the big problem into some subproblems. That is the first point. Divide the big problem into some subproblems. Some people are asking, sir, how many subproblems? Divide the big problem into some subproblems you are saying. Some people are asking, sir, how many subproblems you will do? How many? Right? It depending upon that kind of situation. In that situation, whatever you feel, you do. Some people, can you help, right? India will be divided into, right, so many states. That may be 25, that may be 29, whatever it is, right? If you go to some other country, some other way they will divide. Whatever way you feel better, that point of time, you can do that. Divide the bigger problem into some sub-problem. Some will do 2 parts only. Some will do 10 parts. Right? Some will do 25 parts. Some will do 45 parts. Maybe US may be some other story. Maybe Pakistan may be some other story. Right? So they know very well total country ruling is very difficult. So divide the total country into some small parts. Right? How many parts they will do? Right? Whatever they will feel that point of time, which is better they felt, they will do that only. Right? I am thinking that you are really comfortable. Let's see this one. Divide the big problem into some sub problem. That may be 2, that may be 25. Right? See this one. Total country will be divided into some states. Assume that. Right? 25 states they done. Right? Inside state if you go. Right? I think they may not do 25 and they may do whatever. Whichever is comfortable, they will do that. But here, try to remember here, because of it is after all program. And one more thing is, divide and conquer is nothing but solving the bigger problem in terms of small problem. Right? So our small problem once again divided into again little bit smaller. I think the same thing again. It is a recursion. Try to remember in the divided here. Right? So division is going on, problem to problem differ. What is the meaning? In some countries, right, 25 states, in some country 35 states, in some country 45. Problem to problem it will differ. Some will do always 25, some will do always 45, some will do always 5. Problem to problem it will differ. But the idea is this, bigger problem divided into some small problems. Right? This is the first step. How many small problem? Problem to problem it will differ. Sometimes, right, only 5 sub problems, sometimes only 25 sub problems, something like that. Problem, this is the idea. Divide and conquer is a, right, one kind of algorithm which will give suggestion to you. What is that? Solve big problem in terms of smaller problem. That's what divide and conquer is saying. Divide and conquer is, right, divide and conquer is one of the algorithm designing technique. I am saying now clearly. I don't want to confuse you starting, that is the reason I may not set the truth to you. Now I am saying divide and conquer is one of the algorithm designing technique. What is the meaning? To your problem, if you are looking for some algorithm, right, then you can follow divide and conquer, right, designing technique. To your problem, divide and conquer algorithm, right, designing technique you can follow. It is one kind of designing technique to your problem. If you think that it is suitable, you can proceed. But this algorithm saying that, this divide and conquer is saying that if you think your problem is a bigger problem, right, solve that bigger problem into small problems. Means you have to divide. How will you divide? It is your problem. How you divided, right, you decide yourself. Some people will divide into 5 parts, some people will divide into 10 parts and so on. But one thing, it is a recursion. What is the meaning? Right? Because of it is a recursion, you have to divide again. But one thing, when you are dividing first time, 5 parts you done. When you are dividing second time, again 5 parts. It is a recursion, same thing is repeating again and again. Right? For your problem, first time you done 5 parts, next also 5, next also 5, next also. Some other problem, first they divide into 10 parts, next also 10, next also 10, next also. Problem to problem it will differ, but within the problem, same thing you have to follow. That is the meaning of recursion. What is the meaning of recursion? Doing same thing again and again. So let's see this one. First step. Divide and conquer algorithm, divide and conquer designing technique is saying that first step is going to be take the problem, right, then ask the problem, are you big problem or small problem? Big problem. If it is a big problem, divide the big problem into some sub problems. That is the first step. So first step is over. You have so many sub problems. First step is completed. You have so many sub problems. Before first step, you have a very big problem, only one. After first step is over, you have so many sub problems you have which are smaller, something like that. Now see the second step. You have sub problem. After first step is over, you have a sub problems. Now what will you do? Solve sub problem using recursion. Solve sub problem. Solve sub problem by conquer. Solve subproblem by conquer. Conquer means force. Solve subproblem by force using recursion. Try to remember, conquer is nothing but force. solve subproblems by conquer using recursion. Using recursion means using recursion forcefully solve all subproblems. Try to remember, conquer is nothing but right, using for conquer is nothing but force. Let me read the conquer is nothing but force. Let me read it. Solve subproblem by force using recursion means using recursion, right, by applying the recursion again and again means using some force, right, solve subproblem. I think, let me ask you, first step is over. What will happen? Bigger problem will be divided into some subproblems. So you have subproblem. Second step is saying that using force solve subproblem by calling recursion again and again. How they will, how the subproblems are solved? They may call again using recursion. Call again, do whatever you want. At the end of second step, subproblem solutions you have. How the second step will be done? Maybe recursion is there internally. Some people are saying that problem is big, you divided. It doesn't mean that, right, those subproblems are small. You maybe have to divide again, right? You may divide again if required. That's the meaning of recursion, right? So if subproblems are again big, right, again divide, that will be taken care by recursion. First step is over, you have subproblem. Second step is over, using force by using recursion again and again. Subproblem solution you have to get. Right? See this one, solve subproblem by force using recursion. Right? So you can frame whatever way you want. Right? Solve subproblems by force using recursion. Right? Using recursion, solve subproblem forcefully. Indirectly, directly, that is the meaning. Second step is over means subproblem solutions we have. First problem, right? If those people want some little bit clarification, something like this. See this one. Before first step, it is the problem. See, very big problem. After first step is over, divide the problem into some subproblem. Assume 4 subproblems I divided. 4 subproblem. S1, S2, S3, S4. 4 subproblem. Right? After first step is over, this is the answer. Before first step, no subproblem, only one big problem. First step is over, subproblems I have. Second step is over. What is the answer? Using recursion, solve this subproblem. 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 So when you say second step is completed, what is the meaning? Solve subproblems by force using recursion. Means by calling recursion here, by calling recursion, right? Forcefully again and again. Subproblem solutions you have. Some people are asking, sir, how to get the subproblem solution? Recursion will take care, you don't worry. In further story, that only will come. Roughly you think about, as of now, see, starting itself, you cannot get everything. Divide and conquer, as soon as I started, immediately you don't get divide and conquer. Divide and conquer, right, basics going on. What is that one? What exactly divide and conquer? Roughly how it look like, I am explaining. Problem big, divide. Next one, solve subproblem, that is called conquer. Conquer means by force, right, solve subproblem using recursion. Second step is over, right, subproblem solutions you get. Can you help, your goal is subproblem solution or final problem solution? Final problem solution. Second step is over, subproblem solutions you have. What is the third step? Let me do the third step. 3. Combine subproblem solutions. Combine subproblem solutions so that we will get final problem solution. Combine subproblem solution so that we will get final problem solution. Right? Let me use different color. See this one. Combine subproblem solutions so that we will get final problem solution. Next one. Divide the bigger problem into, right, some subproblems. Solve subproblems by conquer means by force using recursion. These are the main keywords. Divide the problem into some subproblem. That is the first step. Use, right, by using force, right, using force and recursion. Force means recursion only. right? By using force, right? Solve subproblem with the help of recursion. Second step is over. Subproblem solutions we have. Third step, because of subproblem solutions we have, but I want final problem solution. Combine subproblem solution so that we will get final problem solution. Right? Now what will you do? Divide is completed. Next one, conquer means subproblems you solve. Yes, I done. Now afterwards what the answer? Combine them. Subproblem solutions take, combine them somehow, then final problem solution you will get. That's called divide and conquer. From today onwards, if anyone asks you, please explain something about divide and conquer. What will you say? These points you can say. Divide and conquer is one of the algorithm designing technique. That means for any problem, if you want algorithm, right? Divide and conquer is one of the way for that. They will ask you how, right? What will you do? Take the problem, please verify problem is small or big. If it is small, everyone can solve. There is no requirement of divide and conquer. If it is big, if you think that it is big, I cannot give answer, right? Divide and conquer suggesting like this, right? Divide the bigger problem into subproblems. Next, that is the first step. Second step, solve at individual subproblem. Third step, all subproblem solutions you combine, you will get the final problem answer. Divide, conquer, combine. Divide means what? Dividing the bigger one into smaller one. What is the meaning of conquer? Solve subproblem. What is the meaning of combine? After getting subproblem solutions, combine them, you will get the final problem answer. Just say like this. Next question. You are saying divide, right? How many parts I will divide, right? Person to person it will change. Different people will think differently. India is a country, you have to divide. How you divide it? I think maybe 25 states. Maybe US, maybe 45 states. I don't know really, right? I don't know really. Please verify yourself. So everyone having their own ideas. Different people having different ideas. Divide and conquer is a designing technique. It can give idea to you. It can give suggestion. How? First divide. You will get the subproblems. Solve individual subproblem. Then combine them. How will you divide? You decide yourself. It is your problem. You want to divide, you divide whatever way you want. Some people will divide into 2, some people will divide into 10, depending upon their comfortability they will do. But one thing, for one problem, one way of division. For some other problem, some other way of division. Right? To your problem, how you divided, assume that to your problem, I want to divide into 5 parts. What is the answer? I think bigger problem divided into 5 parts. Again, these small problems are again big, assume. Again, they will divide into 5. That is the meaning of recursion. Same thing will repeat. Until your problem is completed, please keep on divide same way. Next one, someone else dividing his problem into, right? I think his big problem into 10 parts he done. Again, those 10 parts are bigger. Again, they will do each one into 10, right? That is 10 array tree will come. Right? My problem I dividing 5 array tree will come. Someone will divide 2, binary tree will come. Person to person different way. This, listen, divide and conquer is the algorithm designing technique. They can give some idea to your problem. You can proceed, right? This idea whatever way you like. They will say divide. They will say conquer. They will say combine. Some people are asking, sir, what is the meaning of combine? Subproblem solutions I have. What is the meaning of combine? Right? To my problem, combine is nothing but add all of them. Plus you can do. To some other problem, combine is nothing but multiplication. To some other problem, combine is nothing but comparison. Problem to problem, you always remember universal solution. For every problem, one solution cannot be possible. Different problems are having different solution, different meanings. As a CSE person, if I say add, some other meaning. Civil branch people add, some other meaning. Mechanical branch people add means some other meaning. Different people, different ideas. In that branch, what is the meaning of add, they know very well. Right? Please be careful. I'm thinking that whatever you got, listen, I said to you 100 things as of now. About divide and conquer, repeatedly I said 100 things to you. Right? If you get the major point, it's okay. 1 or 2 small doubts there, that is the further story. Right? I written on the board also what is the divide and conquer. Divide the bigger one into smaller, bigger one into some sub-problem. Right? All the sub-problems you solve, that is called by using force, that is called conquer. Combine sub-problem solution so that you will get the final problem answer, that is called combine. This is called divide and conquer. So divide and conquer, right? Roughly what is the divide and conquer I already explained to you, right? These are the 3 steps, right? Now see this one, these 3 steps whatever I written, right? I will write this entire story in the form of algorithm. In the form of algorithm, same 3 steps whatever I written, in the form of algorithm I will write. Let's see now, rough algorithm I am writing, right? See this. Please be careful. Divide and conquer roughly I explained. I am writing algorithm. If you are comfortable with algorithm, almost you got the what the divide and conquer is, right? Let me write the algorithm. See this one. I am writing the algorithm. See this. Everyone listen now. Divide and conquer algorithm. See this one. Divide and conquer. Divide and conquer algorithm. See this one. Let us assume that. Let us assume that there is one array A. Divide and conquer algorithm, right? So suppose that this is the problem. See the problem. I am applying divide and conquer algorithm on array A which contain I to j elements. Array A which contain I to j elements. Right? What is the meaning of I to j? I is the first element index. J is the last element index. There is one array in that many elements are there. First element index is I. Last element index is j. This is the array. Array A which contain I to j element. This array I want to sort. Sorting, ascending order, descending order. I want to sort this array using divide and conquer. You have one array which contain I to j element. You want to sort that array using divide and conquer. How will you do? Let's see the procedure. So I written the algorithm. See this one. I written the rough thing. Right? Normal English line I written. Now I am writing little bit systematic algorithm. Right? Carefully listen. Don't confuse. Right? So see this one. One step to another step. You will get more comfortability. Here you have so many doubts. In the previous explanation, you have so many doubts. You got little bit, it's okay, but so many doubts you have. What is the reason? Right? Proper algorithm not there. I am writing the same thing in the form of algorithm. More clarity you will get. More clarity. See this one. There is an array which contain I to j element. Using divide and conquer, I want to sort that array. See the first step. See the first step now. Using divide and conquer, I want to sort array A which contain I to j element. See the first step now. See the first step. If small of A I comma j. If small of A I comma j. See everyone now. If small of A I comma j. What is the meaning? Nothing there. There is a one function small. I will write the code also within few minutes. Right? I will write the code also within a few minutes. There is one function small, right? That small function will decide. Problem small or not. If you want that small function code directly, you can write here also. But anyhow, it is better to write in terms of functions and all. I used one function. Right? Now can you help me? If you want to apply divide and conquer, what is the first step? Please verify problem small or big. If the problem is small, why you will divide? If the problem small, no need to divide. If the problem is big, then divide. Previously, I discussed about only necessary part. Now, when you write algorithm, everything you have to take care about everything. Everything you have to take care about. That's the meaning of deterministic algorithm. Everything you have to say clearly. Nowhere ambiguity should be there. Right? Deterministic algorithm should be deterministic. Right? You cannot write the non-deterministic algorithm. Algorithm should be deterministic. They are practical algorithm. There may be non-deterministic algorithm, they are not practical algorithm. Algorithm, right, when you write program, every possibility you have to cover. Algorithm will be, right, deterministic. Practically deterministic algorithms only there. Right, now see this one. Now carefully listen. If someone asks you, solve this problem using divide and conquer, what is the first step? As soon as you enter inside that algorithm, divide and conquer technique, as soon as you enter, first step is going to be, check problem small or not. How will you check? I think small function code will do that. Please be careful. Within few minutes I will write also. This small function will ask, right? Small function of, small of A I comma j. This function will decide. Within few minutes I will write. Roughly I am writing this one. Small function. Small A I j. This small function will return 0 or 1. If at all supposition that it is a small problem, this function finally return 1. If it is a big problem, it will return 0. Right? So if it is a small function, supposing the problem is small, he will return 1. Otherwise, he will return 0. Please be careful. right? So if it is a small, problem is small or not, true, then he will return 1, otherwise he will return 0. Suppose assume that he return 1, right? So this one, if 1, isn't that small function? Small function returning 1 means problem small, otherwise problem is big. Can you help me now? Suppose if 1 means problem small, then what is the answer? If the problem is small, then answer is going to be, see this one, then answer is going to, because the problem is small, no need to divide also, then return, right? Solution of A I comma j. Because the problem is a small problem, directly you can find the solution, you can return. Some people are asking, sir, this is also a function. Some people are asking, sir, this is also a function, right? I think see this one, whenever a problem is small, directly you can return the solution, right? If you want, you can write directly here, right? If you want, you can use function also, I am using function, right? If you want, I will write that also, small, right? Solution also function, solution A I comma j. What is the code? Within few minutes I will do that, don't worry. Small also function, he will return 0 or 1. 1 means small, 0 means big. If the problem is small, return the solution, right? That is also very small code, within few minutes I will write. So if anyone asks you from today onwards, using divide and conquer technique, solve this problem. What is the first step? As soon as you enter first step, just ask problem small or not. If problem small, return the solution. These two are small, these two are function which contain very small code, right? Within few minutes I will write the code. I written roughly here, within few minutes I will fill that gap also. See, there is a gap. Within few minutes I will fill the gap. Now come to the major story. Come to the major story. Suppose assume that, right? Else, what is the meaning? If 1, then this is. If 1 means what? Problem small, then this is the story. Else, what is the meaning? Problem big. Problem is big. Then major story will start. Problem small, then return the solution. Some people are asking, when can I say small? I will write the code, don't worry. What is the solution? I will write that code also. Supposition that problem is big. Now you came to the major area. Everyone know. When the divide and conquer technique will come into the picture? When the divide and conquer technique will come into the picture is, if the problem big, then you have to divide and all. If the problem is small, why you will divide? What is the use? Right? Problem big, then you have to divide. Then come to the else part. Else part indicate problem small or big. Problem is a big problem. If the problem is a big problem, in the divide and conquer, what is the first step? Right? Divide. Problem big already you know. You have to divide. It is it is already big problem. You cannot solve directly. So best idea is divide the problem. Let me write now. Let me write. Divide. I am writing now. See this one. Divide A I comma j. See, divide also a function. Divide A I comma j. In this array, right? Just divide. Just divide. I think some people are asking, sir, divide also once again function. Of course, right? Divide also function. Within few minutes, I will write the code also. Don't worry. Divide A I comma j. Just major functions I am writing outside so that you will get the clarity. Divide also a function. Just call outside, right? Code is there. According to this code, you will follow. Suppose assume that. Right? Suppose assume that divide function I call E return finally. Assume that this is return finally P. What is the meaning? Divide this array until P. Divide this, right? Just I call the divide function. E will return some number. Accordingly, I will follow. Assume that P. So what is the I? First element position. What is the J? Last element position. Right? Array A which contain I to J. Divide function I applied. It is returning P. Assume. It is returning P. Right? So assume that P also position. Assume. Finally, this function returning some position. Assume that I return. Right? P. Now see the answer. Divide function is over. Assume that it return P. I is the first element position. J is the last element position. Divide function return some position P. Now see what will happen. Now see. So now after divide is over, he is saying that P return some value P return. Now see what will happen. See this one. Make sure that everyone listen is a P, right? So it is also some position. Assume that. See, everyone listen. Everyone. Can you say what is the name of this function? DAC, divide and conquer. Now see the answer. Using recursion, DAC. Using recursion, right? Array A which contain, right? I to P element first to sort. What is our goal? I want to sort array A which contain I to J. I to J element I want to sort. Right? If at all, if you want to sort I to J element, now what he is saying is, see this one, I to J elements you have to sort, I to J element you have to sort. So what the divide is running, he divided somewhere here he divided, this is position is P assume. Now, using divide and conquer, I to P element you sort first. Using divide and conquer, I to P element you sort first. It is the recursion, you will take care. They will internally call, don't worry. Isn't that? It is completed, you got the sub-problem answer. Isn't it? S1. Using divide and conquer, right? Sort the first half, I to P. Yes, I done. Recursion will take care, don't worry. Next one more. See the one more. Using divide and conquer, array A which contain P plus 1 to J, some P, some position P. Using divide and conquer, P plus 1 to J, right? So that half also you sort. Right, this P plus 1 to J, that half also sort. Isn't that using recursion, this also done. So second half answer also I got S2. This is the first subproblem answer. This is the second subproblem answer. This divide function dividing the given problem into two subproblem. On the left also apply recursion, on the right also apply recursion. So using recursion I done. So left problem answer I got S1. Using recursion I done the second part also. Second part answer is S2. Just divide is saying that with respect to P I will divide. Yes. Right. With respect to P divided two parts. Right. So left part complete, you got S1 answer. Right part also you complete, you got S2 answer, like that. Now can you help me now? What is the S1? First half answer. First subproblem answer. What is the S2? Second subproblem answer. Some people are asking how you got the answer. This recursion will take care. How you got S2? This recursion will take care. Why it is called recursion? See, DAC calling DAC. Recursion. So can you help in how many people will go? After these two function calls are completed, you got the first half answer, you got second half answer. You want first half answer or second half answer or total problem answer? Total problem answer. Then what will you do is, you have to do like this one. What is the answer? Combine. Combine. S1. First subproblem answer, second subproblem answer. You combine, right? You combine. Assume that after combine is completed, you got something. Final answer is assume that yes. I got final answer yes. Then finally return yes. Return yes. End of the else part. Right? Some people are asking, sir, what is the meaning of this combine? Try to remember, combine also a function. Let me write here. Combine. Combine also a function. Can you say for this combine algorithm input, right? Subproblems answers, S1, S2. Output, final problem answer. How to combine? I think are they adding, subtracting or multiplying? I will write the code within few minutes. Right? Combine algorithm input is going to be subproblem solution. Output is going to be final problem solution. This is also a function. Within few minutes I will write the code. Divide also a function. Right? Within few minutes I will write the code. Finally, return the solution. Right? So next one. Let me minimize it. Let me minimize roughly. So this is the divide and conquer algorithm. Right? Return as. Now can you help me know what is this area? Small problem, this is the story. Big problem, this is the story. If the problem is small, this is the story. If the problem big, this is the story. If the problem is big, what is the first step? Divide. According to division, automatically sub-problems will come. This divide function dividing into two equal parts assume. This divide function dividing into two equal parts. Then write two parts. So recursion on the left, recursion on the right. Suppose this divide function is dividing three parts, right? Divide and conquer on the first one, divide and conquer on the second one, divide and conquer on the third one will come. Because of only two there, right? Like that. It is the divide and conquer algorithm. Now some people are asking, sir, what you done previously? Previously I written normal English line. Divide the bigger problem into some subproblems. Next one, solve subproblem. Next one, combine subproblem solution so that you will get the final problem answer. So for every step, whatever thing I written in the normal English line, I written the algorithm. Right? I written the algorithm. Let me ask you one small and please listen. Can you help me now? Right? I think from the last few classes I am saying one line very importantly. That line I am repeating again. Can you help me now? In the recursion, if condition is important or else condition is important. From last few classes I am repeating this line. In the recursion, if condition is important or else only. Else only important. If is only for stopping purpose. Else is the major. That is the reason. This is the else part. Else part I explained. Else part only I explained initially. Right? That only important. Right? But when you write algorithm, everything you have to write. So if part, else part, both the things I written. Else part is major important. Please be careful. Can you help me now? Is it recursive program? Yes. DAC calling DAC. Divide and conquer is calling divide and conquer. That is the reason recursion. DAC calling DAC. DAC calling DAC. Right? Fine. And one more. Please help me now. Right? This is the only else part. Please map now. Please map. Map both the things. Can you map both the things? Major part only I written. This is the algorithm. Let me map now. Let me map. See this one. Divide function. It divide the right. Divide function purpose. Divide in the given program. See first line. Right. This is the divide. It is the divide. Right. First line. Divide. Divide the big problem into some sub problem. Can you help in here? How many sub problems you done? 2 sub problem. See 2. Based on this P it will come. He may divide whatever you want. Assume that divide is dividing. Right? Within some people are asking how you say 2 parts. Right? I will write the code also. Don't worry. Divide function, how it is dividing, I will write the code. What is the meaning of small? I will write the code. What is the meaning of solution? I will write the code. What is the meaning of combine also? I will write the code. Don't worry. Can you help me now? Divide, right? Divide the bigger problem into some sub problem. This divide step will do. Next one is going to be solve sub problems. See this one. Solve sub problem. Yes, that is called conquer. See, solve sub problem by conquer means by force using recursion. Right? This is going to be conquer. This is the conquer. Next one. Combine subproblem solution so that you will get the final problem solution. See, combine subproblem solution so that you will get final problem. This is called combine. Major lines I written. I am minimizing again. See, this is the story. Else part, major things I written. Now, systematically one algorithm I written. Fine. Divide, conquer, combine. What is the meaning of conquer? Subproblems using recursion, solve subproblem. What is the meaning of combine? Subproblem solutions you will take. Final answer you will get. What is the meaning of divide? Dividing the bigger problem into some subproblems. Right? This is the small, then return the solution. Don't worry that much about this area. Right? I am thinking you are really comfortable. Let's see. Now, one more thing I want to ask you. In this program, what are the functions available? In this divide and conquer algorithm, right? What are the functions you are using? I am using 4 functions. In this divide and conquer algorithm, right? 4 functions I am using. What are those? Small, solution, divide and combine. It is a recursion. Conquer is a recursion. Conquer area is recursion. Right? Divide, combine, small, solution. Now can you help me now? In this divide and conquer algorithm, you are using 4 functions. Can you list them? Small, solution, divide, combine. 4 functions you are using. And one more thing I want to ask you. 4 functions you are using, it's okay. What about 4 functions code? 4 functions code. Can you help me now? What about 4 functions code? Try to remember. This 4 functions code, problem to problem will change. Supposition that for one of the problem, I am using divide and conquer technique, assume. I have one problem, I want to solve that problem using divide and conquer. Using this algorithm, I want to solve my problem. Then what will you do? Same algorithm only will be there. Using this algorithm. What is the meaning of using divide and conquer? Using this algorithm, I want to solve my problem. Then what will you do? Because of it is my problem, using this technique I want to solve. In this technique, 4 functions you are using. Small, solution, divide and combine. Right? 4 functions. To my problem, those 4 functions code I should write. Gaps are there. So, listen, to my problem, I am using this algorithm, right? But in this problem, in this algorithm, 4 functions are there. That code you have to write. To my problem, to solve, I am using this algorithm. This algorithm internally contains 4 functions. That code you have to write to your problem because you know very well what is your problem. How to combine, how will you, right? Your problem is small when you are thinking. Your problem is small when you are thinking. If it is small, what you have to do? If it is big, how will you divide? Right? After getting subproblem solution, how will you combine? You know very well about your problem. Right? So, you have to fill all those 4 gaps. I am repeating, it is a very, very interesting line. Let me write now. Can you help me now? I have a problem. I want to solve that problem using divide and conquer. Means using this algorithm. I want to solve that problem. But using this algorithm means this algorithm contains internally 4 functions. That code I should write. To my problem to solve using divide and conquer, 4 functions code I have to write myself. Supposition that I don't know how to write. I am facing some difficulty. What is the meaning? Your problem, right, cannot be solved using divide and conquer according to your opinion. right? So please remember this one. If you can fill those, then indication that your problem is application of divide and conquer. Right? Supposition that, see, to solve your problem using this algorithm, you have to fill that gap. If you are able to fill gap, means your problem is one of the application of divide and conquer. In the similar way, like divide and conquer, there is a greedy technique also. It is also having some algorithm. It is internally having some function. That code you should write. For your problem, greedy algorithm, major functions, whatever code is there, that code if I can write, means my problem is application of greedy technique. If at all, if I can fill those gaps, so my problem is application of divide and conquer. Supposition that to my problem, divide and conquer also possible. Greedy also possible. Dynamic programming also possible. Assume that all the techniques are saying that, all the designing techniques are saying that to your problem I will give answer. Everyone saying, then for a particular problem more than one algorithm is available, more than one algorithm is available, whichever will take less time, that will be my answer. Right? Please be correct. Last time I want to ask you, please listen everyone. When can I say my problem is application of divide and conquer? When can I say, right? Your problem is application of divide and conquer. When can I say is going to be, right? So this function, this divide and conquer algorithm contain 4 major functions, right? Those four major functions, right? Code, if you see gap is there. To your problem, please fill those gaps. Please fill those gaps. If you are able to fill those gaps, nice way, right? Nice divide and conquer algorithm for your problem you will get. Supposition that while filling, you are taking lot of time inside and all, right? I think divide and conquer algorithm to your problem possible, that may be worst algorithm because you written the worst way. You always remember, right? So if I say my problem to solve, I used the divide and conquer technique, but it is taking lot of time. Reason maybe you written the worst code. These 4 functions will decide the story. These 4 functions code, if you write in the worst way, right? I think divide and conquer algorithm becomes worst. Supposition that you are unable to write it, indication that maybe this problem is, right, your problem may not be solvable using divide and conquer. If you write in the efficient way, isn't that you completed efficient way, I think best divide and conquer algorithm you got for your problem. Some people will complete this one, right, by taking lot of time inside and all. I think maybe worst divide and conquer algorithm you design. But try to remember, finally, your capabilities will decide it here. So one of my friend is saying that to your problem, divide and conquer algorithm is possible. Divide and conquer algorithm is possible, but that algorithm will take a lot of time. What is the meaning? While filling, he got to know that lot of time is required. One more friend is saying that to your problem, divide and conquer algorithm is possible, but it will take very less time. What is the meaning? I think he filled in the nice way. One more friend is saying that to your problem, divide and conquer algorithm not possible at all. What is the meaning? While filling, he got to know that he cannot fill it. So something like that. Person to person, it is keep on changing. If you have more experience, right, you will get the nice answer. If you have less experience, right, you may get the worst answer. Please be careful how much experience you have in this. Now, one more interesting thing I want to say to you, just listen carefully. Using same algorithm, right, 10 crore problems are solved. Algorithm is same. 10 crore problems are solved. What is the reason? Inside this algorithm, 4 major functions are there. Those 4 major functions code problem to problem keep on changing. Right? That is the reason I can say using same algorithm, many problems are solved. Suppose someone asks you, can you solve your problem? Can you solve this problem using divide and conquer? What is the answer? Using divide and conquer, you want to solve that problem, which is nothing but these 4 gaps. You want to fill it to that problem, right? Try your level best. Some people are asking, sir, how to fill? That's what we will do in further stories. Right? Maybe in this class or next class, we will see that only. Now, can you help me one small? What is the divide and conquer roughly? I explained like this. Normal English line. Right? Whatever you said, please write in the form of a systematic algorithm I written. In this algorithm, right, if part is not that much important, else part is important. If you see the else part, divide, conquer, combine. Conquer means what? Recursion. Right? Before recursion, right, in the else part, whatever is there, divide. After recursion, whatever is there, that is called combine. Right? Please be careful. Next one, in this particular algorithm, major functions are 4. Those 4 functions code not written. What is the reason? These 4 functions code is not written. The reason is going to be problem to problem. These functions code will keep on changing. That is the reason this algorithm name is called, right? That is the reason this algorithm name I am writing also. See this one? Divide and conquer. Divide and conquer. Abstract algorithm. Abstract algorithm. It is the divide and conquer abstract algorithm. What is the meaning? Abstraction means what? Hiding. What you are hiding? Major functions code we are not writing. Major functions code we are not writing, right? We are hiding. That is the reason it is called divide and conquer abstract algorithm. It is the divide and conquer algorithm. Something we are not showing. What is the reason? It is not possible because problem to problem it will keep on changing. If you say to this problem, right? Divide and conquer algorithm please design, then I can fill it because I know problem. Accordingly I will plan it, right? If someone asks to write the divide and conquer algorithm, not with respect to problem, write the generalized divide and conquer algorithm. It is like this. Divide will do divide, combine will do combine, small will check problem small or not, solution will return the solution by doing small work, divide will divide the problem. Some people are asking, sir, how it will divide? How you return the code accordingly. In the code if you mention, it will divide into 5 parts, it will 5 parts. In the combine, if you written the code, that combine means multiplication, it will multiply. That code will decide. 4 gaps I written because with respect to problem, it will change. Can you help me now? What this is a divide and conquer algorithm or not? Yes, it is a divide and conquer algorithm for any problem or generalized one. Generalized one means when you say generalized one, right? Code I cannot write. When you cannot write code, this is called divide and conquer abstract algorithm, right? Please be careful. Problem to problem, it will change. Now, okay, one more interesting question I want to say to you. Just listen this also. Using same algorithm, binary search will be done. Using same algorithm, quicksort will be done. Using same algorithm, merge sort will be done. But merge sort time complexity, worst case n log n. But quicksort worst case n square. Using same algorithm, right? Merge sort also done, quicksort also done. Quicksort worst case n square. Merge sort worst case is n log n. Some people are asking, you are saying same algorithm, how time complexity will differ? Same algorithm, it's okay. But inside major functions, 4 functions are there. That code changing. So inside algorithm, code is changing. Automatically time complexity will change. Using same algorithm, 10 crore problems are solved. Right? Because of same algorithm, 10 crore problem, you cannot say that all will take same time and all. No, depending upon what code you written. Right? I am thinking that you are little bit, you got the, what is the meaning of divide and conquer. Can you help me now? Divide and conquer. What is the meaning? Just check first of all, small or big. Small, nothing to do. Return the solution. Big, then first step, divide. Next conquer. Next combine. You got some rough idea. And one more. Whenever you say it is a recursive program, termination condition compulsory. See, it is the termination. If small, return. See, no recursion. If small, then return. No, right? No recursion. Big, then recursion there. Whenever big, then recursion will be there. I'm thinking that you are almost comfortable. Right? Why it is called abstract algorithm is major function code is gap is there. With respect to problem, it will keep on change. I'm thinking you are absolutely fine now, right? Let's see the next one. Let's see next one. See, until now, I roughly explained what the divide and conquer. That is the first thing. Next one, whatever I explained to that systematic algorithm I written, yes, fine. Right? This algorithm is a right abstract algorithm because major functions code. Right, problem to problem changing, I cannot write, right, because specific to problem only I can fill this, right, we don't know, right, this algorithm is going to be general idea of divide and conquer algorithm. Divide means what? It will divide. How many parts? Maybe 2, maybe 3, like that, right, this divide function will decide. Suppose inside the divide function, if I say 100 parts you have to do, then 100 parts, 100 function calls will come. Right? So inside the small, can you say what is the meaning of small? One element is there normally small. Array A which contain I to j element. This is a small problem. When if array contain only one element, sorting the array is a small problem. Some people are asking array contain one element, sorting the array is a small problem. Why? That itself is answer. Some people will say that, right, array contain 2 elements, then also small problem because 2 elements are there to sort the array. One comparison, that is also small. One element is there, no comparison at all, then also small. So that is the reason I am saying. Someone will say that, right, to my problem, one element is there, then only small. Someone will say that to my problem, 2 elements are there, then only small. Someone will say that to my problem, 10 elements are there, then small problem. But one thing, all are in terms of constant only. So that is the reason, lot of flexibility. If I say one only small, means I am forcing. If we give more flexibility, more users will come. Something like this one. So Google Play Store and the Apple Store also. Apple Play Store and Google Play Store, see both the things, right? In Google Play Store, very less conditions will be there, right? In Apple Play Store, many conditions will be there. That is the reason, right? Many people may not keep the apps inside the Apple Play Store, but many apps are there inside the Google Play Store. Just give the lot of, right? If you keep more condition, less people will come. But one thing, it doesn't mean that, right? It doesn't mean that, right, iOS people are bad. It doesn't mean that Google people are good, something like that. It doesn't mean that. Both are having their own stories. That is called as business logic, right? Every company having their own logic. First of all, they will, before doing itself, they will get to know what is that one, what is my goal, right? I think Apple people goal may be rich people, something like that, right? Google people goal is going to be all the people. Right? Apple is only rich people. Everyone having their own stories. You may say that, sir, how you can concentrate only rich and all? Right? It is none of your business, because it is not your story. Right? They know very well about their stories. Right? You concentrate on your story. Now, final conclusion I want to say to you. Final conclusion. Right? I cannot say forcefully one element only small. I cannot say forcefully 10 only small. Percent whatever they feel for their problem, they can write. Some people are saying that, sir, how he can divide whatever way you want? It is his problem, he will divide. Divide and conquer, simply saying that if you think that problem is a big problem, divide. How many parts? It is up to you. You write. Suppose it is that 5 parts I want to divide, write 5. Write the code accordingly. Accordingly, you can manage the major one also. Right? Next one. Some people are asking, sir, what is the meaning of solution? Only one element, then small problem. Return that element. That itself is sorting. Only two element, that is a small problem. Then compare both the element, right? Comparing the first one, second one is bigger. Then return as it is, otherwise swap it and return. So depending upon small, solution will change. So, but one thing is true, it is better to, instead of keeping the more conditions and all, right? Let's give the gap. They will fill whatever way they like. That is the meaning of template. You are giving the process, this is the way how it will be done, but at this place, do whatever way you want. This is you will say the procedure. Do first step, do second step, do third step. But while doing the third step, right, do whatever way you feel comfortable. First step, whatever way you feel comfortable to your problem, you can do that. That's okay. I think these are small things, that's fine now. So first I explained roughly what the divide and conquer. Only else part I written. Next one, I written the algorithm, proper algorithm I written, if part and else part. Our goal is only else, right? But while writing this algorithm, you will get to know some major functions are there, small solution, divide, combine, something like that. Major functions code I am not written, so that is the reason it is abstract algorithm, that is also okay. Now come to the one more major story. Divide and conquer algorithm. There is a problem to that problem. Divide and conquer algorithm I written. What is the meaning? To solve a particular problem using divide and conquer technique, I designed the algorithm. Right? See this one, divide and conquer algorithm means that is the meaning. For a particular problem to solve using divide and conquer technique, I designed the algorithm. Right? See this one, divide and conquer algorithm, time complexity finding. It is a major one, please be careful. Time complexity finding. Divide and conquer algorithm, time complexity finding, how I will explain. This is very crucial. Divide and conquer algorithm, time complexity finding, how. The meaning of this line again I am repeating. There is a problem, to solve that problem, one person is written, divide and conquer algorithm. What is the meaning? I think this program is written and inside code also is written. Small function code according, because you know, right, to his problem when is small and all. To solve a particular problem, someone is written the divide and conquer algorithm, means those 4 functions code also is written. Right, complete algorithm there. Using divide and conquer, he solved his problem. Complete code is available. The next question is going to be, right, this algorithm, whatever he completed, it is taking how much time? If anyone solved his problem using divide and conquer technique, next question is going to be how to find out time complexity. See, divide and conquer algorithm, time complexity finding, how I will explain now. It is going to be very interesting one, please you take care. Right? So, divide and conquer algorithm, time complexity finding, how I am explaining. See everyone now. It will trouble you if you don't listen. So, I am starting. See this one, I am starting. Can you help me now? See this one. See the interesting line. See the interesting line now. See this one. Using divide and conquer algorithm, array A which contain I to j elements. Using divide and conquer algorithm, array A which contain I to j, assume that I to j means assume that I to j elements, assume that n elements. I to j contain n elements, assume. So now I am repeating once again. Using divide and conquer algorithm, I want to solve a problem. Using divide and conquer algorithm, I want to solve a problem which contain n elements. I am repeating once again. This is the critical terminology. Please listen. Using divide and conquer algorithm, I want to sort one array which contain n elements. Assume that using divide and conquer algorithm, if you want to sort one array which contain n element, assume, right, on n elements, divide and conquer algorithm will take tn time. What is the meaning of tn? I am repeating once again. Tn is nothing but using divide and conquer algorithm to sort an array which contain n element. Time complexity tn assume. Right? Now I am writing. See this one. Tn is equal to see this one. Amount of time required. Tn is equal to amount of time required to sort an array of n elements using DAC algorithm. That is the meaning. I written the whatever I said, I written also. T of n is nothing but amount of time required to sort an array of n elements using DAC algorithm. Now I am saying once again now, see, this DAC algorithm on n elements will take time complexity Tn. Please be careful. This DAC algorithm on n elements will take time complexity Tn. Please remember, right? If you are okay, now see this one. Can you see what is the topic going on? If you solve any problem using divide and conquer algorithm, time complexity finding, how? Right? First step. Right? So, DAC algorithm on n elements will take Tn time. I written. Right? I written. Next one. See the next one. Now, Tn is equal to, see the answer. How to find out Tn? Tn means time complexity. Amount of time required to sort an array of an element using DAC algorithm. So, assume that this algorithm on n element will take Tn time is equal to, careful listen, is equal to, you only say, first step. As soon as you enter, this algorithm time complexity, assume Tn, what is the Tn you have to calculate? This is Tn you are given, right? This will take Tn time. First of all, what is the Tn? I explained also. Now, how much Tn you will calculate now? Tn definition you given. How to find it? Definition is okay. How to find it? If you want to find out, go inside. Yes, I am going inside. Can you help me now? If you go inside, what is the first step? N element DAC algorithm Tn time, right, is equal to, Tn is equal to, what is the first step? If small, return the solution. If small, return the solution. Can you help me now? Here more elements are there or less elements are there in this area? In this area, if you observe, less elements are there. Small, then return. That small may contain one element, maybe two elements. This area contain very less elements. So, you only say very less elements are there, one or two comparison, constant time. So, I am writing. Time complexity of DAC algorithm on n element Tn is equal to, see this one, Tn is equal to, see the answer. Time complexity Tn is equal to, answer is constant, order of 1 if, right, time complexity Tn is equal to constant if what is the answer? N is small. If n is small, Tn is constant. From today onwards, if anyone asks you, divide and conquer algorithm on n element time complexity Tn, what is the Tn? What will you say? What is the Tn? Answer is going to be constant if n is small. If n is small, no need to apply divide and conquer because starting itself you can stop. That is fine. That is nothing there. Until now, nothing happened. Let's come to the major story. Suppose if it is big. If small, then constant time. That's okay. Come to the next one now. Else part. Can you help me in the else part? What is the first step? Divide, next one is conquer, next one is combine. Now you only say, can you help me now? I2j, how many elements are there? Assume that I2j n elements are there. Then DAC on n elements is Tn. Can you help me now? DAC on n elements Tn time, it's okay. Now can you help me now? What is the name of this algorithm? DAC. DAC algorithm on n elements is Tn time. You only say DAC algorithm on I2P. Assume that I2P n by 2 elements are there. Assume I2j, assume that n elements. Then Tn time. DAC algorithm on n element Tn time. If you believe that is true, right? DAC algorithm on I2P, assume that I2P is n by 2. Assume. Then DAC algorithm on n by 2, time complexity Tn by 2, recursion. So n element time complexity Tn, same algorithm n by 2 element Tn by 2. Same algorithm, assume that here also n by 2 elements, right? It is also Tn by 2, right? Please be careful. So I am explaining the else part. After entering inside else part, recursion is recursion. Main algorithm DAC on n element Tn. Next one, same algorithm DAC n by 2, Tn by 2. Recursion is recursion. Same algorithm on n by 2. Suppose if it is n by 3, Tn by 3. If it is n by 4, Tn by 4. If it is 5, T of 5. That is the meaning of recursion. Now can you help me now? Right? As soon as you come to the else, what is the first step? Divide. After divide is over, next one, conquer. Next one, combine. I think conquer is already over. What is the reason? Conquer means recursion. Recursion in terms of recursion. Tn in terms of Tn by 2, something like that. Recursion. Divide. Next one, combine. Now let me ask you one small line now. Divide algorithm time complexity how much? You have to divide, afterwards conquer, afterwards combine. Conquer is okay because of recursion already we done. What about divide? Try to remember. This divide is a normal line or function call? If this divide is a function call, if it is a normal line, constant. If it is a function call, right? Divide is a normal line or function call? Normal line means nothing there, constant. If it is a function call, you only say if it is a function call, compulsory, there is a code. If it is a function call, code should be there. When you say divide is a function call, please go there. There is a code. Based on the code, you can analyze. Suppose even that inside this divide code is there, but inside code there is no loop is there, constant time. Suppose inside this particular divide function code is there, but there one for loop is there which is running n time. Time complexity of divide algorithm is n. Try to remember this particular function time complexity based on inside that function what code is there. Inside that function one loop is there, n time. Inside that code, inside that particular function no loop is there, constant. Inside that function 2 inner loops are there, maybe n square. Now once again I am asking you, divide function time complexity, when you say function, code will be there, go and verify. But because of it is the abstract algorithm, I am not written anything, right? It depending upon problem. It is the abstract algorithm, no code is there. Assume that divide function will take some name I have to give because code is not there, right? F1 of n times. If at all, what is the F1 of n times? Some function that may be constant, that may be log n, that may be n. Can you say F1 of n function? What is the F1 of n? Divide time. Can you say F1 of n is a divide time, right? Can you say what is the F1 of n time boundaries? Minimum is 1 time, minimum 1 because constant time, minimum is constant. That may be, I think maximum may be n power n, maximum may be n factorial depending upon what code is there. Because of it is the abstract algorithm, divide code if I go, not there. So let's give some name, right? Divide time complexity F1 of n. It may be constant, it may be log n, something like that. Conquer is always available because major one is Tn, n people DAC Tn, right? Half people DAC n by 2. Half people DAC n by 2. That is okay. Next one. Divide function. Assume that it will take F1 of n time. Can you help me now? Combine function. I think combine also a function. When you say function, code is there. Because of code not available. Depending upon code, this value will come. Because of no code, let me give some function. Assume that F2 of n is the combined time. Because next one, I think it is a normal statement only, constant time. Can you say who will take time complexity directly, indirectly? I want answer from you. Many times I repeated. Who will take time complexity directly, indirectly? Loops only. What is the meaning of directly, indirectly? Directly loop is there, right? Order of n. Supposing that loop is not there directly, indirectly. What is the meaning? Function call there, if I go there, there is a loop. Time complexity means indirectly, directly loops only. Sometimes loop is directly visible, sometimes indirectly. What is the meaning? Here someone, if I go there, loop is there. So it is not a function call, it is a keyword, one keyword which will take constant time. It is a function call. Please go and check the code. Code not there. So depending upon code, I have to analyze. Code not there. Instead of saying not there and all, let me give some function. F1 of n, divide time. This is going to be conquer time. Next one is combine time. Can you help divide time? F1 of n. Conquer time 2tn by 2. Two function call. Two function call of half size. Right? One function call of full size is tn. Right? Two function calls of half size 2tn by 2. Can you say combine time? F2 of n. Now let's see this one. Time complexity of DAC algorithm on n elements. Tn is equal to small problem, constant, big problem. What is the first step in the else part? Divide F1 of n time. Next one, conquer tn by 2, two function calls. Next one, combine F2 of n. This is, what is the answer? If n is small or big, right? If n is big, small, this is the story. Big, this is the story. If n is big, time complexity of DAC algorithm on an element Tn is equal to small problem, this is big problem, this is big problem. What is the first step? Divide. Divide time. This is conquer time. This is combine time. So I written roughly, please be careful, right? So F1 of n is one function. That may be constant, that may be log n, depending upon code. That is the meaning of abstract algorithm. Depending upon code, I have to give, because of I don't know, I given some function. Combine code also I don't know, I given some function. F2 of n is combine time. This may be constant, this may be log n, this may be n log n. Next one, depending upon how you divide, number of function calls will come. Some people are asking, sir, how can you say equal? Sometimes may not be equal also. This may be n by 3, this may be 2n by 3. This may be n by 5, it may be 4n by 5. Depending upon divide, right, recursion story will come. Roughly I written, isn't there two function call, equally divided. This is divide time, conquer time and combine time. Let me simplify further, right? So let me simplify. See this one, if I continue further, I am simplifying. Tn is equal to, careful listen, Tn is equal to, what is the answer? I think Tn by 2, 2Tn by 2. Next one, F1 of n plus F2 of n. F1 of n plus F2 of n. See this one, it is the F1 of n, divide time. It is the F2 of n, combine time. Both combinedly F of n. See, same thing I written, right? Just compressed way, Tn by 2, 2Tn by 2. If sometimes compression may not be possible, when is the Tn by 3, it is the T2n by 3. It is the n by 3, right? It is the n by 3, right? It is going to be, because both are equal size, I written 2Tn by 3. This is n by 2, this is n by 2, 2Tn by 2 I written. If these two are not equal, I cannot write. Two function calls, each of size n by 2. Two function calls, fine, each of size n by 2. Suppose it is the n by 3, it is the 2n by 3. Two function call, but both are not same size, then I cannot write. Possibility there I simplified, possibility not there I cannot simplify. So Tn is equal to 2Tn by 2 plus F of n. Can you say what is the F of n? Divide time and combine time, because it is internally contained F1 of n plus F2 of n. Can you help me? F of n boundaries? F of n boundaries, minimum may be constant, because this is constant, constant maybe log n also, this is constant, this is log n, constant plus log n, anything can happen depending upon code. Next one, see the next one. So what are the two? Two function calls. What is the n by 2? Size of every subproblem. 2 means 2 subproblem, n by 2 means size of each subproblem. So can you help me now? Tn is equal to 2Tn by 2 plus F of n. F of n is the divide time, combine time. See this one, in general. Everyone listen, in general. In general, see the answer, in general. A subproblem, each of size n by b, F of n, amount of time required for both divide and combine. What is the A? Number of subproblems. What is the n by b? Size of each subproblem. What is the f of n? Divide time and combine time. I am writing now. Number of subproblems. Number of subproblems. This is going to be size of subproblem. This is divide time and combine time. Divide and combine time. So try to remember, right? See this one. In general, all the divide and conquer recurrence relation look like this. In general, all divide and conquer recurrence relation look like that. How? A t n by b plus f of n. They will look like this. What is the A? Number of subproblem. What is the n by b? Size of each subproblem. F of n, divide time and combine time. Some people are asking me, sir, this one somewhere we seen. Of course, this one you see in master theorem. To solve these kind of recurrence relation, master theorem is invented. If anyone asks what is the master theorem basic purpose, what is the answer? To solve divide and conquer recurrence relation, master theorem is invented. But anyhow, we are not interested at all. Master theorem purpose, recurrence relation solving. Right? Please be careful. I hope everyone fine. Now, can you help me once? Whatever you got until now, it's okay. Let me ask you one small line. Can you say what is the topic name? What is the topic name? Topic name is going to be, if any problem is solved using divide and conquer algorithm, time complexity finding how, this is the way. If any problem solved using divide and conquer, time complexity finding how, right? What is the way? This is the way you have to analyze. So, some people are asking, sir, how to analyze like this one? Nothing there. Listen, nothing there. Right? See this one. To this recursive program, write the recurrence relation using this model. From today onwards, if anyone asks you, listen carefully, from today onwards, if anyone asks you, to this recursive program, right, how to find out time complexity, what is the answer? Using like this, using this model. First, write the recurrence relation. After getting the recurrence relation, solve it. You will get the time complexity. Divide and conquer algorithm, time complexity finding how. What is the answer? To this recursive program, which it may be, listen, it may be divide and conquer. Is it recursive program or not? Yes. To this recursive program, which is the divide and conquer technique and all, that is fine. Right? To this divide and conquer algorithm, how to find out time complexity. First, write the recurrence relation like this. After writing the recurrence relation, solve it. You will get the time complexity. Now can you help one interesting line? This may be confuse you, but let me say one small line. Can you help me now? Divide and conquer algorithm, time complexity finding. This is the procedure, it's okay. But one thing, divide and conquer algorithm is a first of all recursive program, right? Recursive program, time complexity also same. Please be careful. Recursive program. Divide and conquer algorithm, time complexity like this in the similar way. Recursive program, time complexity also same. Now, from now onward, divide and conquer algorithm, time complexity finding how? First step, write the recurrence relation like this. Solve it, you will get the time complexity. One more thing I want to ask you. Divide and conquer algorithm, time complexity finding is like this, it's okay. But what about recursive program, time complexity finding? Same, because divide and conquer algorithm is a recursive program only. From now onwards, please be careful. Right? Any recursive program is given. If you want to find out time complexity, first step, write the recurrence relation like this. Solve it, you will get time complexity. I'm thinking you got. Again, I'm repeating. It's a very, very important line. Any recursive program is given. That may be divide and conquer. That may be anything. I'm repeating once again now. Any recursive program is given. That may be divide and conquer. That may be non-divide and conquer. That may be dynamic programming. Anything. Any recursive program is given. If you want to find out time complexity, just write the recurrence relation like this. Solve it. You will get the time complexity. Right? And one more point I am stressing. Please be careful. Right? Listen this also. Listen. Recursive program is given. Recurrence relation you write like this. Recurrence relation you write like this, then you solve it, you will get the time complexity. But few days back in previous lectures, if you observe, right, for the given recursive program, we written the recurrence relation. That may be factorial, that may be GCD, that may be Fibonacci, right? Few days back, right, for the given recursive program, we written the recurrence relation. Now also we written the recurrence relation. But what is the difference between them? Try to remember, few days back for the given recursive program, we written the recurrence relation. Now also we written the recurrence relation. Difference is going to be those recurrence relations for not time complexity. They are for value. Factorial of n value. Recurrence relation. Factorial of n to find out. Factorial of n to find out. Write the recurrence relation and recursive program. That is that recurrence relation for finding factorial of n value, not time complexity. One more. To find out nth Fibonacci number. Write the recursive program, recurrence relation. Previous recurrence relations, whatever you written previously, they are for value, but this is for time. From today onwards, you remember, right? This is also very, very important line. One recursive program is given. Right? Recursive program is given. Can you write the recurrence relation or not? Yes. Recursive program is given. You can write the recurrence relation. That is fine. But try to remember, for the given recursive program, recurrence relation you can write, it's okay. But recurrence relation writing many ways. If you write like that, this is called time complexity. If you write like previous classes, factorial, Fibonacci, GCD, right? Multiplication. If you write the recurrence relation like that, that is for value. If you write like this, this is for time. Recursive program is given, recurrence relation you can write, but not one way, many ways. Some people will write the recurrence relation for time purpose like this. Some people will write the recurrence relation for value purpose like previous. Please practice. If anyone confusing, you are confusing means at the new point. Some people are thinking that they are confusing means, right? They are incapable and all. They are cheap and all. They will think like that. Something I am explaining, it is confusing you. Indication that this is the nice point. I think it will give some marks to you. So difficult things cannot come easily. Now, okay, whatever it is, you know very well. Something confusion is there. I am repeating again. Can you say until now what you are thinking? Recursive program, recurrence relation only one way. No. Recursive program, recurrence relation many ways. Some recurrence relations for time, some recurrence relation for value like previous. Some more will come in further classes. That is the reason. From starting class onwards of algorithm, I am saying again and again one line. Don't by heart algorithm subject. Use brain, use common sense. Right? Automatically you will get. Now can help you now. Now interesting answer. To this recursive program, how to find out time complexity. It may be divide and conquer, it may be anything. To this recursive program, how to find out time complexity. What is the answer? Write the recurrence relation like this. After writing the recurrence relation, see this one. Tn for what? Tn for what is the answer? Time required. Time complexity purpose, write the recurrence relation, solve it. Then you will get the time complexity. And one more thing I want to ask you. In the previous classes, if you see recursive program given, recurrence relation you written. Those recurrence relations, if you solve, that recurrence relation also you can solve. If you solve those recurrence relation, they are written for value. You will get value. Some people are thinking that after solving recurrence relation, I will get the time. No. What purpose you written that recurrence relation? Based on that required thing will come. Time purpose you written like this, time will come. Value purpose you written, then value will come. Something else purpose you written, something else will come. Please be careful. Conclusions I am saying to you. Conclusions. Recursive program is given. Can you write the recurrence relation or not? Yes. Next one. You can write the recurrence relation, it's okay. But how many recurrence relations you can write? Depending upon what you want. For that I can write. If you want time purpose, write. If you want value purpose, you write. Next one. If you write the recurrence relation for time, if you solve it, you don't get value, you will get time. If you write the recurrence relation for value like previous, if you solve it, you will get value but not time. Some confusion may be there, right? I think in the maybe next few minutes, maybe it will be clarified. Please be careful. Can you say topic name? Recursive program, time complexity finding how? What is the answer? Write the recurrence relation for a time. I am not saying write the recurrence relation. Write the recurrence relation for a time. Then solve it, you will get time. Next one, divide and conquer abstract algorithm. Next one, what is the basic idea of divide and conquer? Like this. Please be careful. This is the very, very interesting story. Divide and conquer, right? I think basic idea I written. Next one, on that idea, I build the algorithm. When you say algorithm, deterministic algorithm, most of the things you have to cover, I covered. But something I am not able to write the code because it is abstract algorithm. It is not specific to a particular problem. It is right. It is generalized algorithm. Next one, divide and conquer algorithm, time complexity finding how, which is nothing but recursive program, time complexity finding how, right? Like this. Like this. Total problem is tn time, right? Recursion will take tn by 2, tn by 2. Next one, before divide function, go to the function and see the code. Suppose in that code, no loop is there, constant. In that code, one loop is there, n. In that code, two loops are there inside, n square. Because of I don't know what the code and all, I given some function name. I didn't return n square. I didn't return n. I return some function name. That may be anything. Combine also, it is a function. Go inside and see the code. No code is there. I return some function. So recursion, that is okay. So like that you solve it, you will get the answer. Next one, some people are asking me, what is the purpose of master theorem? What is the answer? Those reconciliation which will generated by divide and conquer. To solve them. To solve them, master theorem is there, right? If you use for some other purpose also, no problem, right? Master theorem basic purpose, solving divide and conquer kind of recurrence relations. These three things, if you are really comfortable, right? I think further story becomes very simple. I hope you are fine now, right? Fine, right? In the next one, we will see the remaining stories. Right now, see some examples on how recursive program time complexity will be computed. See the topic name. Recursive programs time complexity finding how. Recursive programs time complexity finding how, we'll see now, right? In previous classes, recursive program time complexity finding how I explained, but that time I explained, right? Manually I done. Manually, you know very well. When you do manually, right, there may be chance of small mistake will happen. When you do manually, there may be chance that small mistakes will happen. That time, right, you don't know how to solve recurrence relation and all. That is the reason I didn't explain, right? But that time itself I remind you, in further classes, one nice procedure is there, I will explain, right? I will explain this. That time whatever I done, that is also okay, this is also okay. That is manual checking. When you do manual checking, new problem will come. You may do wrong answer. You may give wrong answer. But when you follow some standard procedure, you never do wrong answer. Manually, previously I done, those are also correct. But the problem is, when you do manually for the new problem, you may do mistake. If you don't want to do mistake at all, right, just follow this procedure. Recursive program, time complexity finding how. Can you help me now? How? Standard procedure. One recursive program I will give to you. How to find out time complexity? What is the answer? For the given recursive program, if you want to find out time complexity, first step, write reconciliation for time. Don't write reconciliation blindly. Some people are asking, sir, how to write reconciliation? Nothing there. For the given recursive program, if you write the reconciliation as it is, no change at all, as it is you return the reconciliation, that is for value. If you use little bit of common sense, what is the meaning of common sense? Time complexity means loops. By thinking about the loops, if you do, right, that is called time complexity. For the given recursive program, many reconciliations will be there, right? For the given recursive program, as it is, if you return, as it is copy, that is called a reconciliation for value. Suppose if you think about the loops and all, and if you write the reconciliation, that is for time complexity. So anyhow, I will explain few examples, right? Using standard procedure, recursive program time complexity finding how. Few examples I will give. Let me try this, right? Let me try. See the first problem. Previously also I done, that is the manual checking. Manual checking, if you do, sometimes you may give wrong answer. If you follow systematic procedure, it never be wrong. Follow this procedure. From now onwards, recursive program time complexity, please follow like this, right? See the first example. Example 1. One example I am writing. See this one. See everyone now. Factorial of n. If n less than or equal to 1, return 1, that's okay. If n less than or equal to 1, return 1, else return n into fact of n minus 1. fact of n. If n is less than or equal to 1, return n, else return n into fact of n minus 1. To this recursive program, right? Write the, if you want to find out time complexity, write the recurrence relation for time, please be careful. Right? Some people are asking, sir, as it is I will write, see this one, as it is. If n, listen, n is less than or equal to 1, then 1 is the answer. N is less than or equal to 1, then 1 is the answer. Otherwise, n into fact of n, as it is, if you write, that is value. Let me write the recurrence relation for value. You know very well, only for namesake I am writing. See this one. See everyone now, I am writing the recurrence relation. See this one, recurrence relation for value. Recurrence relation for value. Value means same thing, as it is you write. See how I am writing. Factorial of n is equal to, same thing you know very well. To this recursive program, right? Recurrence relation I am writing for value. Value means as it is. What is that one? Answer is 1. Return 1. If n less than or equal to 1. As it is, see, n less than or equal to 1, return 1. Otherwise, as it is, you write n into f of n minus 1. If n greater than 1. If you write as it is, this is for value. See, recurrence relation for value. As it is, you are writing nothing. See, some people are asking me, how I know it is a value? As it is, you are writing, that is value. If you think about loops, that is for time. Right? Now I will write the time complexity recurrence. See this one. To this recursive program, recurrence relation for value completed. Right? Let me write now. See this one. I am writing now. Recurrence relation I am writing. Carefully listen. To this program, recurrence relation I am writing for time. Recurrence relation for time. Let me write. Some people are asking, sir, what is the meaning of time? Let me check. See this one. See everyone. It is the first problem you are doing, right? Recursive program, time complexity finding systematically how? See this one. Recurrence relation for time. See the answer. Fact of n. Carefully listen. Fact of n is in the time complexity Tn. Fact of n, time complexity Tn is in. Let me write now. Let me write. See this one. Before writing recurrence relation itself, you have to define what is the meaning of Tn. See this one. Recurrence relation for time. See what I am writing. Tn is equal to time complexity of, you have to define time complexity of fact of n. See everyone now. Fact of n, time complexity is Tn. Fact of n, time complexity Tn. What is the meaning? This Tn is time complexity. Please be careful. What is that Fn? What is this Fn? Fn is this value. If you want, I will write here. If you want, I will write. See this one. Fn is equal to, what is the answer? Value of fact of n. This fact of n value is Fn. Then this is the way. Right? Next one. This fact of n, time complexity Tn. How to do? I will explain. See this one I am starting. Tn is equal to. Right? Let's start now. Can you help me now? You only say. Time complexity means loops. Please be careful. Can you help me now? Come to the else part. If part, else part. It is the if, it is the else. Can you help me? In the if part, if you observe, n less than or equal to 1, return 1. In the if part, n less than or equal to 1, in the if part, is there any loop? No loop, return 1. So, this answer. Tn is equal to constant time, because of no loop is there. In the if part, if you observe, no loop is there. Right? Time, see this one. Factorial of n, time complexity Tn is equal to constant time if n is less than or equal to 1, because no loop. There is no time complexity called 1, 2, 3, 4 like that. Right? Time complexity you want to say no loop is there. Constant, we go off 1. Now see the interesting one. Next line. Right? Come to this area. Can you help me now? Fact of n, time complexity Tn. Carefully listen. Fact of n, time complexity Tn. If you are okay with that. Fact of n minus 1, time complexity Tn minus 1. Recursion. Fact of n, time complexity Tn. Right? Fact of n minus 1, time complexity Tn minus 1. That is fine. Tn minus 1. That is also okay. And one more. In the else part, if you observe. Carefully listen. In the else part, if you observe, is there any loop? In the else part, is there any loop? No loop. See, fact of n, Tn. Fact of n minus 1, Tn minus, this is already over. This is already I taken care. So, fact of n, time complexity Tn. Fact of n minus 1, time complexity Tn minus 1. That is okay. But if you see the remaining part, in the else part, if you see remaining part, no loop is there. One for loop is there, which is n times going. Then I will write n. See this one, there is no loop here. In the else part, no loop. fact of n Tn, fact of n minus 1, Tn minus 1, that is fine. But in the else part, no loop is there. If no loop is there, how can we write plus n? Right? Because of nothing there, plus c you write. C is a constant, nothing there. Loop is there, then only plus n, no loop is there. Even though here n square there, I don't write n square. Even though here log n there, I don't write log n, because no loop. No loop means constant. To this function call, to this function Tn, to this function Tn minus 1, because of no loop, constant. Right? Please, some people are asking one more interesting line. Suppose assume that fact of n is Tn, that is fine. Fact of n minus 1 is Tn minus 1, that is also okay. Suppose assume that, this also not there. Fact of n is Tn, in the else part, fact of n minus 1 not there, only n there, then constant. Then constant, because so loop is there, then only n will be. Time complexity, if anyone written n, what is the meaning? One loop should be there. Time complexity, if anyone written n square, two inner loops should be there. Time complexity, if anyone written log n, what is the meaning? There should be a loop which is going on log n time. Please be careful. Can you help me in the else part? In the else part, this is the else part. In the else part, why no n, no loop is there. In the else part, why t came, right? Recursion means t. Major one n, Tn, right? N minus 1, Tn minus 1. In the else part, no loop, plus c. C is a constant if n is greater than 1. Please be careful. It is the reconciliation for time. That is the reconciliation for value. And some people are asking, sir, if you solve this reconciliation, what I will get? Because of you written for time, you will get time. Let me solve it. Let me solve. I am solving this one. Tn is equal, I am solving, you know very well, Tn is equal to T n minus 1 plus c. Solve it using substitution method. T n minus 2 plus c, already 1 c there. Substitute one more time, T n minus 3 plus c, already 2 c's are there. If you do 3 times, this is the story. Right? If you do n minus 1 time, what will happen? 3 times I got 3 c's. N minus 1, n minus 1. If you want, you can write k also, no problem. T n minus 1. 3 times means 3k, n minus 1 means n minus 1. Plus, what is the answer? N minus 1 into c. 3 times means 3c, n minus 1 means n minus 1 into c. Which will goes to what the answer? T of 1. n cancel 1. Plus n minus 1 into c. Right? Next one, what is the T of 1? T of 1 is constant. Right? Let me write. Which will goes to order of 1 plus, right, n minus 1 into c. Finally, which will goes to big O of n, because left side, right side, bigger function same. You can write big O of n. You can write omega also, you can write theta also. If you want, you can write theta. So, now I think it is the correct time to ask you, please help me to this recursive program, time complexity. To this recursive program, time complexity. What is the answer? Write the reconciliation for time, solve it. You get finally n. This recursive program, previously also we computed time complexity manually. Manually we done. We got the same answer. Manually if you do same answer, if you do this one, same answer. If you do manually in GATE examination or any competitive examination, if new problem will come, it may trouble you. Some people are asking, then why don't you say directly this, right? First of all, you should know recursive program, what is going on. What is going on recursive program, right? Internally same thing you done, but it is systematic procedure. If I say directly, you don't know what is happening. So I want to say, right, the purpose previously we explained is going to be, right, the reason for this one, previously we reconciliations are many types. Those reconciliation for value purpose, these are for time. Please be careful, don't confuse. In GATE examination or some other examination, they will give recursive program, they will ask you reconciliation for time, you have to give this. Reconciliation for value, you have to give this. In the options, both will be there. It will trouble you. So, please do meaningfully, practice it. If at all troubling, some confusion is there, try one more problem. Try one more problem. If you do that, you will get the answer. So, if you think that you are getting some trouble and all, I also got. Starting everyone have to get, because all are human beings. Suppose him that starting itself someone is not troubled, means he may be Rajinikanth. Starting itself not troubling. Complex topic will come, right? Then everyone have to trouble. If someone is not troubling, maybe he is Rajinikanth, maybe he is God. Right? Every normal human being have to trouble. right? Recurrence relation for the given recursive program many ways. That is for value, you solve that one, value you will get. You solve this one, you will get time. Some people what they are doing is, recurrence relation they will write for a time. They will solve, they will say value. They will write the recurrence relation for value. They will solve, they will say time. No. What you want, for that you write recurrence relation, solve it. You will get that. I'm thinking you are a little bit okay. Let's go one more problem which may give more clarity. Right? Take the one more problem. Example 2. See the example 2. Fibonacci of n. Fibonacci of n. If n less than or equal to, let me write now, n less than or equal to if n is equal to 0 or n is equal to 1, then return n, else return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Right? End of this. This is the recursive program. Fibonacci of n, right? N is equal to 0 or n is equal to 1, return n, else return Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is the example 2 to this Fibonacci, right? I want to find out time complexity. I think one more thing I want to ask you. To this Fibonacci program, do you know how to write the recurrence relation for value? Already we done. Already to this particular program, already recurrence relation for value we written. That time you are thinking time, no. To this Fibonacci value purpose we written the recurrence relation, it's okay. And time complexity also I computed manually. You know very well, big tree came. To this recursive program, time complexity also we computed manually, very big tree came. Left side is n levels, right side is n by 2, right? I think very big tree, which may take almost like 1 hour I explain. I want to explain clearly what is going on inside. I explained that also, right? If you do like that in the GATE examination, right, the thing what will happen, it may take more time. When you do something more time in the exam, right, lot of tension will be there. You may get the wrong answers also. What is the best idea? Recursive program is given. You want to find out time complexity, write the recurrence relation for a time, solve it. If you write as it is, that is called value, you know very well. If you want, I will write value recurrence relation also. Let me write now, value recurrence relation. Let me write. I am writing now. See this one. In this story, whatever I am going to write in this story, Tn is equal to, right, value of Tn is equal to value of Fibonacci of n. See this one, recurrence relation for value. Recurrence relation for value. So see this one, I am writing Tn is equal to value of Fibonacci of n, right? See this one, Tn is equal to Fibonacci of n is equal to, as it is you write. Then what is the answer? N is equal to 0 or 1, return n. See this one, answer is n, return n if n0 or n1, as it is. Otherwise what is the answer? Otherwise, let me write T n minus 1, as it is you write, plus T n minus 2 if n greater than 1, right, like this. Tn is equal to value of Fibonacci of n, then, right, as it is you write, this is for value, right. Let's come to the time complexity means loops. See, while writing this one, nowhere I bothered about loops, but while writing this one, I will bother about the loop. If you want, you can check, right. See the answer. See the answer, everyone. Recurrence relation for time. Recurrence relation for a time I am writing now. Tn is equal to recurrence relation for a time. Tn is equal to, see the answer, time complexity of Fibonacci of n. Tn is equal to time complexity of Fibonacci of n, right? If you are okay, now see the answer. Tn is equal to time complexity of Fibonacci of n. You only say this will take time complexity Tn. If you believe this is true, Fibonacci of n time complexity Tn, if you believe, Fibonacci of n minus 1 time complexity Tn minus 1, Fibonacci of n minus 2 time complexity Tn minus 2, right? Everyone know, right? Next one, here is there any loop? No loop, nothing. What is the answer? Constant time I am writing now. Tn is equal to constant time if n is equal to 0 or n is equal to 1. Otherwise, else part. In the else part, what is the answer? Fibonacci of n minus 1 is Tn minus 1. Fibonacci of n minus 2 is Tn minus 2. That is okay, right? See this one. This will take Tn minus 1. That is okay. This will take Tn minus 2. That is also okay, right? After getting this answer, you have to add, which may take constant time. Which may take constant time, right? Please be careful. So, but one thing, try to remember, see, everyone listen, in the else part, recursions are there, write recursions first. How many recursions are there in the else part? Those many you write. Next one, in the else part, after writing the recursions, please be careful. If any loop is there, one loop is there n time, then write plus n. If at all one more loop is there in the else part, inner loop, n square you write. Suppose nothing there, suppose in the else part, other than recursion nothing there, then write plus c. But one thing, one non-recursive term compulsory. While writing the time complexity, in the else part, right, recursions you write first. Afterwards, any loop is there, right, n you write. Inner loops n square. If no loop is there, then write constant. Every time, so when you come to the else part, minimum constant time it will take. Minimum. You came to the else part, means you are doing some work. Minimum constant time. If you go to the if part, there also constant time. If you go to the if part, minimum constant. If you go to if part is normally will take constant only every time. But if you go to the else part, minimum constant. If nothing there, write constant. Recursion is always there. Recursion is always there. Those things. Other than recursion, non-recursive term C. Nowhere loop is there, right? Plus C you write. If anyone don't write plus C, indication that in the else part, no time is taking. No. If you come to anywhere, minimum constant time. So here constant, I written. Here if you come recursion, it's okay. Remaining no loop is there, plus C. If loop is there, right? Depending upon loop, you can write. So this is the reconciliation for time. If n is greater than 1. Now, if you solve this one, what is the answer? This one, let me solve. Tn is equal to Tn minus 1 plus Tn minus 2 plus C, right? Some people are asking, sir, how to solve this? Yesterday we done, right? In the last class we done, right? What is that one? Using recursive tree method, you can solve this problem using more than one recursive tree method required, right? If you want, I will do roughly this reconciliation. If you solve, what is the answer? N, this is the n. Divide into two parts, n minus 1, n minus 2. But one thing, n it divide into two parts, it's okay. But n it will take C. Non-recursive time is C required. Again here also. What is the answer? I think left minus 1, right minus 2. Same way to this one. Minus 1, n minus 2. This is minus 2. Right? For this one, minus 1. For this one, minus 2. Right? It will take C time. This is also same. Minus 1. Minus 2. This is also C time. C plus C, 2C. First level, second level differ. So series going on. If you want, you can check next level. 2 square C. At the 2 power 1 C. At the 2 power 0 C. It will continue. Can I help you now? Left is always subtracting 1, 1, 1. Right is always subtracting 2, 2, 2. If you always subtract 1, 1, 1, what is the answer? Right? To become 1 approximately. What is the answer? N times you have to subtract. N times. Always subtract 1, n by 1. Always subtract 2, n by 2. Larger one is n because I want to give upper bound. Larger one you take. So it will goes to n times, right? 2 times if you do 2 square, 1 time if you do 2 power 1, right? N times if you do 2 power nc, right? Upper bound. These people, right hand side person n by 2 only will stop, but left will go n, right? Upper bound I am giving. Let's solve this one. Tn is the actual answer. Upper bound means less than or equal to. What is the series? C common. 2 power 0, 2 power 1 and so on. 2 power n. Right? Less than or equal to some C into. If you solve this one roughly, you will get 2 power n, which will goes to big O of 2 power n. You know very well. Fibonacci of and time complexity. Upper bound 2 power n. Some people are asking, why upper bound? What is the answer? Actual answer computing not possible. Upper bound. Either lower bound. So this side is n levels, but this side how many? N by 2 levels only. This side is only n by 2 levels, but here n levels, right? See this one. Right? This is more. This side is more, this side is right. It is only n by 2, right? If you want, I will write little bit roughly. Right? Let me write roughly. right, like this. It is the n levels, it is the n by 2. Right side is n by 2, left is n, right? So assume that right also n levels, right? Upper bound, right? 2 power n. What is the lower bound? 2 power n by 2. 2 power n by 2. What is the actual answer? Tn. Upper bound is 2 power n, lower bound is 2 power n by 2, because the both are not equal, theta not possible. You know very well, Fibonacci series time complexity 2 power n. Let me write. Fibonacci series time complexity, actual answer Tn. Actual answer means what? This diagram only, Tn. To this diagram, if I add like this, extra I added upper bound, that is going to be 2 power n. Right? So suppose if I cut here itself, lower bound, what is that answer? 2 power n by 2. It is the lower bound, it is the upper bound, actual answer Tn. Some people are asking, why are you finding upper bound, lower bound? Actual answer finding not possible. Then go for upper bound or lower bound. That time big diagram I written. Right? So that time whatever is possible we done that. Always you take latest things. Starting class itself, how can I say all? If I say all, right, people may confuse. My goal is not saying facts and all, right? I don't want to confuse the students. Latest things you take in my lecture, right? Day to day you will progress. Right? But one thing, for now itself I am concluding, time complexity of any recursive program, if you want to find out, write the recurrence relation for a time like this. Like this, write the recurrence relation using any one of the method, recursive tree method, substitution method, whatever method you feel, using that you can solve. Right? Finally, to this problem. Can you say final answer? To this recursive program, time complexity, what is the answer? Time complexity Tn is equal to big O of 2 power n. It will be there in the option. If it is not there, it may be there. If it is not there, it may be there. Suppose, right? Suppose these two, right? So this is there, Then one more option, C, both. This is also correct. It is the lower bound, it is the upper bound. Option, right? If it is there, only one there, select only one. If both there, one more option, both, right? That may be the answer. So I am thinking that you are more comfortable now. Recursive program time complexity, manual is one way, which will be trouble you, which may give sometimes from your side wrong answer also, because you have to do lot of big procedure. Standard procedure is this. Follow this. From now onwards, follow. It is the correct time to say this story. I done that. I am thinking you are comfortable. Right? Fine. Right. Let's see this problem also. One small problem there. See this problem also. Example. One more problem. See, interesting one. It may solve one more small mistake. What you are going to do? A of n. If n is equal to 2, return 1, else return a of root n. A of n, if n is equal to 2, return 1, else return a of root n. I am thinking that this is the given recursive program. How to find out time complexity? Let me find out directly time complexity. How to find out time complexity? See the answer. What is the first step? If you want to find out time complexity, see this one, right? If you want to find out time complexity for this problem, first step, what is the answer? Recurrence relation for time purpose you should write. Let me write now. Recurrence relation for time, you want to do this. See, this is the way. Tn is equal to, what is the answer? Time of A of n. Time complexity of A of n is T of n. Time complexity of A of n is T of n. See this one? A of n time complexity Tn. If you believe this is true, right? A of root n time complexity T of root n. Recursion is recursion. A of n time complexity Tn, A of root n time complexity T of root n. Right? So now let's see this one. Recurrence relation Tn is equal to, and one more. From now onwards I am saying to you, please remember, for the given recursive program, when you are writing recurrence relation, see this one. For the given recursive program, when you are writing recurrence relation, before writing only, please define what purpose you want to write. See, recurrence relation for time purpose. If you say simply recurrence relation, it is wrong. If anyone asks you, see, if anyone asks you, to this recursive program, this recurrence relation is given, solve it, then solve directly, don't bother. To this recursive program, he will give recurrence relation, he will ask you solve it. If at all he will say solve it, what is there in that? Suppose, to this recursive program, right, write recurrence relation and solve. If he say like that, then it is mistake. Recursive program is given, recurrence relation also given, then solve, directly solve. Recursive program is given and is asking, write recurrence relation from your side and solve. Then you have to ask one line, for what purpose I should write recurrence relation? Time purpose, then write. Recurrence relation for time, then do that. Value purpose, then write the recurrence relation for value, then write that. If you don't say anything, if you say recurrence relation, you have to ask. See this one, recurrence relation for time. So Tn is equal to time of An. Now see the answer, An is equal to, what is the if part? See, if part, if you want, you can check. No loop, nothing there. What is the time? Constant time. What it is written? Say return 1. Returning 1 will take constant time. Simply returning will take constant time. You know this very well. Right? Return constant. It is directly available. Return 1, constant time. If n is equal to 2, this is the story. N is equal to 2, time complexity constant. Otherwise, come to the else part. Can you say in the else part what the answer? T of A of n is T of n. A of root n is T of root n. That is fine. In the else part, A of root n, T of root n, it's okay. And one more, no loop is there. No loop is there. So nothing is there. Plus C, you write constant time. Some people are asking, sir, how constant? When you come to this area, see this one, returning itself will take some constant time. Right? Next one, here root itself you have to do. Right? I think small work. When you come to this area, constant time required. More than constant there, then don't write constant. Right? More than constant C, nothing there, then you can write plus C. Right? Constant time. If n greater than 2, right? This is the one. If you solve this, right? What is the recurrence relation? Let me write Tn is equal to T root n plus C. Right? Using master theorem, you can do this. Answer is going to be log n. If you want, you can do yourself. Right? Theta of log n. Please check yourself. In the last class, we done already. Right? I think you are fine. Loop, right? So nowhere loop is there. Nowhere loop is there. That is the reason this is the answer. Let me do one more problem. One more problem. Example 4. Example 4. Let's see this. A of n, if n is equal to 1, then return 1, else. It's not return 1, isn't that? Return n square. Return n square, else. Carefully listen, else C is equal to A of n minus 1 plus A of n by 2 plus A of n by 2. Next one, for I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z. Right? Something like this. Some program I have to write. I written this. Don't bother about syntax errors, semantic errors. Don't bother. Time complexity only. Time complexity means what? Our goal is loops only. Time complexity means loops only. Please be careful. Right? Now I am starting. Right? Let's start this. This recursive program, how to find out time complexity. Can you say what is the first step? Right? See this one. Recurrence relation for what you write? Recurrence relation for time. Now that means Tn is equal to, right? Tn is equal to what is the answer? Time of An. Time of An. Tn is equal to time of An. When you write this line, the meaning is going to be this An will take how much time? Tn. Right? This An by 2 will take, so what is there inside? You are least bothered. Your goal is loops only. An time complexity Tn, An by 2 time complexity will take Tn by 2. Recursion is recursion. In this nothing special. Recursion is recursion. This will take Tn by 2. Right? I think until now. What is the answer? Let me write. Tn is equal to, if part, what is the answer? If part. See, can you help me now? If part, what is the answer? No loop. Some people are saying n square there. N square there means time complexity not n square. 2 inner loops are there, n square. Right? N is there, not time complexity n. One loop is there, n. Here no loop, nothing. See, no loop is there. So Tn is equal to constant time if n is equal to 1. Otherwise, come to the else part. Else part already 2 function calls are there. Who are those? Tn by 2, Tn by 2. What is the answer? 2Tn by 2 already there. 2Tn by 2. See this one. This one Tn by 2. This one Tn by 2. And one more. After writing the recursive term, this is the every time will come. Is there any loop in the else part? There is a loop. Loops only. Time complexity means loops only. Is there any loop? Yes. Can you say this loop will repeat how many times? N time. Then plus n. Until now, it is the fourth problem. Before that, 3 problems I done. In the else part, no loop is there. So constant. In this problem, else part, loop also there. Plus n. If this loop is inner loop, then n square. If this loop is here n square will come. Because this loop is n square term, you know very well, right? Fine, plus n if n is greater than 1. If you simplify this one, Tn is equal to 2Tn by 2 plus n, right? Using master theorem, you can solve. This answer is going to be theta of n log n. Answer is n log n. Right, fine. This is the example 4. In this problem, else part loop is there, n time, then I return n time. 2 function call. Forget about small thing, remaining all. Some people are asking me, right, one loop is there, you return the n, it's okay. But remaining small work is there, plus c you have to write. If you want, you can write plus c. N plus c is n only. That is the reason I didn't return. If n dominating factor not there, c you have to write. Dominating factor there, dominating factor you write. Right, this is example 4. Let's go for example 5. Example 5. See this also example 5. A of n, if n is equal to 1, then return n square n plus 1, else, see the else now, for I is equal to 1, I less than or equal to 4, I plus plus a of n by 2 for I is equal to 1, I less than or equal to n square, I plus plus x is equal to y plus z. Right, to this recursive program. One more recursive program is given. To this we have to find out time complexity. Please be careful for this. To this program, please be careful. Try to remember this one. I am repeatedly said to you many times. Many times I said to you, recursive program is given, time complexity finding how? Write the reconciliation and solve. Then you may say that, then why you said previously like that, right? If you want to find out time complexity of recursive program using this approach, you should know recurrence relation, types of recurrence relation. Next one, recurrence relation solving, many things required. That time whatever is possible, manually we done, that is also right. But from now onwards, don't do that. For those problems, whatever I said, right? Those problems, whatever I said, those also okay, right? That is okay. New problem will come. Please follow this. Like this, whatever I am doing, like this you follow. Can you help me know? This recursive program, time complexity, how? What is the first step? Recurrence relation for time. Right, not only that, you have to define first, so that you will get more clarity. Tn is equal to, what is the answer? Time of a of n. Right, if you are okay, Tn is equal to time of an. In this problem, you may do small mistake. Please be careful, right? Please be careful here. See this one. Tn is equal to, small mistake you may do. That is the reason I am giving this problem. See this one. If place, that's okay, normal, constant time. If n is equal to 1, that is okay. Right? This will take constant time, it's okay. Can you help me now? An will take how much time? Tn. That is fine. An by 2 will take how much time? Tn by 2. That is also okay. Right? So, an by 2 will take Tn by 2, that is okay. Can you help me now? Is there any loop here? Yes, this loop. Can you say this loop is how much time? N square, that is okay. So, can you help me now? Inside this else part, if you observe, right, how many loops there? 2 loops. One loop is n square time. This is also loop. This is also loop. Can you help me now? This loop is how many times? 4 times. This loop is 4 times. Right? Can you help me now? Inside this particular else part, 2 loops are there. One loop is n square, it's okay. But if you see the first loop, how many times? 4 times. But one thing, first loop is 4 times, it's okay. But every I value, right? an by 2. Every I value, an by 2. What is the meaning? I think an by 2 4 times. Instead of writing an by 2, an by 2, an by 2 4 times, they kept inside loop, they written an by 2, which is nothing but, it is not 1 tn by 2, 4 tn by 2, because here 4 functions are there. They may be, they written intelligently, right? So it is not 1 tn by 2, 4 times tn by 2, because every I value an by 2. Please be careful. So what is the else part? an by 2 4 times, so 4 tn by 2. If 2 times there, 2 tn by 2 in the previous problem, now here 4 times. Can you say what is another way of writing the same thing? This one another way of writing, right? This one another way of writing, an by 2, 4 times they can write, right? But they don't want to waste their time, they written in the nice way using loop. So same, 4 function calls are there, 4 tn by 2 plus, so what is the next one? N square. If n is greater than 1. Right? If you solve this one, 4 tn by 2 plus n square using master theorem, whatever it may be, tn is equal to theta of n square log n will come. Right? To this problem, answer is n square. 2 loops are there. Inside the loop, there is a function call. That is 4 tn by 2 came. If this loop is not there, only tn by 2. Because of this loop, 4 tn by 2. Right, next one. This is, I think, they are right. They are not inner loop. They are one after another. After this I over, next I will start. I am thinking you are fine now. 5 problems I said, time complexity finding of recursive program. Right, fine. Please be careful. Right, don't do manually. From now onwards, do using this procedure. Right, fine. Thank you.